What if I told you that two ordinary pencils, yeah, the kind you have lying around right now, are holding on to some pretty amazing mathematical secrets? Well, today we're going to unlock them. Just look at this thing. It's beautiful, right? This vibrant, twisting sculpture. It wasn't just dreamt up by an artist. Nope, it was actually generated using the simple logic of two pencils spinning in space. And we're about to find out exactly how.
So, welcome to what I love to call the two-pencil game. Honestly, it's one of my all-time favorite ways to explore math because it proves how simple rules can create the most incredible things. It's perfect for a classroom or really just for a fun afternoon at home.
Okay, the rules couldn't be simpler. You just need two pencils. The first one, we're going to call it the axis. It stays perfectly still, totally fixed. The second one, the generator, now that's the star of the show. It's going to rotate all the way around the axis. And the shape it traces in the air, that's what we're here to see.
All right, let's warm up. We'll start with a couple of arrangements you probably already know, just to get a feel for how this whole thing works.
First up, two parallel pencils. See? The axis is on the left, the generator is on the right. Now, if we spin that generator pencil all the way around the axis, what shape do you think it's going to trace? Go on, take a guess.
And if you guessed a cylinder, you got it. Absolutely right. A perfect cylinder. It kind of makes sense, right? The distance between the two pencils never changes, so it just traces this smooth, even wall all the way around.
Okay, let's try another one. This time, the pencils are touching at their tips. The axis pencil, that one's still fixed. So what do you think happens when we spin the generator pencil now? And just like that, we get a cone. That point where they touch, it stays put, while the other end of the generator pencil just swings out in a big, wide circle. Boom! A classic cone. So far, so good. We've made a cylinder and a cone. Easy enough. But what happens when the pencils don't intersect and they're not parallel either? Uh-oh. This, my friends, is where the real magic happens. Now, to get what happens next, we need a new idea. Skew lines. It sounds fancy, but it's simple. They're just lines in 3D space that will never, ever cross, but they aren't parallel either. Just imagine two airplanes flying at different heights on totally different paths. Their flight paths are skew. And we can do the exact same thing with our pencils.
So here's our setup. One pencil is the axis, the other is the generator, and it's held at this weird angle in space. They're skew. So take a second. What could this possibly make? It's definitely not a cylinder, and it's not a cone. Any ideas?
Get ready for this. It creates this absolutely stunning shape, a hyperboloid of one sheet. I mean, look at that. A beautiful, curved, hourglass-looking surface that seems totally impossible because it's made entirely by a spinning straight line. And you've seen this shape before. Think of those huge cooling towers at power plants.
And if we make those lines longer, whoa, the shape gets even more dramatic. You can really see that graceful, sweeping curve just appearing out of nowhere from what is still, believe it or not, just a bunch of straight lines spinning around.
But this isn't just some cool trick on a computer screen. This is the big idea. These simple geometric rules that we just discovered by playing around, they are the foundation for so much modern design and manufacturing. Let's see what happens when we bring it into the real world with 3D printing. Check this out. You take that same skew line rotation, and you can design a totally functional, and let's be honest, really cool-looking pencil holder.
Or, hey, why not scale it up? Now you've got a desk sculpture that holds dozens of pencils, and each one slots perfectly into the path of that original spinning line.
The design possibilities here are just endless. It's a perfect example of form follows function. And in this case, the function is guided by a really elegant mathematical rule.
And this model shows it perfectly. See how each individual pencil is just one straight line, tracing a path on that curved surface? It is literally math that you can hold in your hands.
So that's the two-pencil game. But the best way to really understand something like this is to feel it for yourself.
And here's the best part. You don't even need pencils to give it a try.
Seriously, think about it. Your body, that's the axis. Your outstretched arm, that's the generator. Now just spin like a dancer. If your arm is parallel to your body, you're tracing a cylinder. If you point it down, you make a cone. And if you hold it out at an angle, you become a human hyperboloid. Go ahead, give it a try. So, we've seen how two simple pencils can generate these incredible forms, all just through play. It really makes you wonder, doesn't it? What other everyday objects are just sitting there, waiting for us to play with them and uncover all the mathematical secrets hidden inside?